ध्यायामोद्धवलावगुण्ठनवती तेजोमयीं नैष्टकीं स्निग्धां पाङ्गविलोकिनीं भगवतीं मन्दस्मितश्रीमुखीं वात्सल्यामृतवर्षिणी सुमधुरं सङ्कीर्तनालापिनी श्यामाङ्गी मधुसिक्तसूक्तिम् अमृतानन्दात्मिकाम् ईश्वरी अमृतानन्दात्मिकामीश्वरी अमृतानन्दात्मिका ईश्वरी.
My humble pronouns at the lotus feet of our beloved Amma, Mother, Guide, Guru, Guide. Om Amriteshwaraya Namah. Welcome to today's session on a powerful mathematical concept that underpins many machine learning techniques, the pseudo inverse of a matrix. We are delighted to have today's speaker, Mr. Soman sir, with us, who will guide us through both the theory and practical applications of the pseudo inverse, especially in the context of machine learning tasks and the rapidly evolving field of generative AI. It gives me great pleasure to introduce our esteemed speaker, Dr. Soman KP, Sir, Dean of School of Artificial Intelligence and School of Computing at Amrita Vishwavidyapita. He also heads the Department of Computational Engineering and Networking, Coimbatore. With over 27 years of distinguished experience in research and teaching, Dr. Soman Sir has authored more than 500 publications and 4 influential books. He is among the world's top 2% most influential scientists, as recognized by Stanford University, and one of the most cited researchers in artificial intelligence and data science at Amrita. Beyond his research accomplishment, Dr. Soman sir has mentored more than 20 PhD scholars and leads innovative programs in data science and AI at Amrita. His current work explores AI in DNA sequence analysis, reinforcement learning, computer vision, and cyber physical systems. Thank you, sir. Please join with us today, sir.
Good evening to all. Pseudo inverse and applications for or application in machine learning and deep learning. So in this talk now, I am going to basically talk about how to introduce AI. AI is now becoming a requirement for all science and engineering. And my personal opinion is that it should go to high school level. Okay, so question is how to bring down this mass to school level. So we were working on that one. To a certain extent, we could do it through the concept of pseudo inverse. And there itself there is a problem. Conventionally, pseudo inverse is taught at PG level and PhD level. Then some institutions at third year, fourth year of engineering, very less. Because it requires very heavy linear algebra. But we could bring down those maths to school level. So we'll see that one. So we recently, based on that one, we published a book. It is available in Amazon. Foundations of Multidisciplinary AI for scientists and engineers. Several volumes will be coming, but 3 volume we are just planned. It will cover most of current AI with basic linear algebra. So the topic you should both data science AI. You should focus is one is linear algebra, second is optimization theory, and third one is probability theory. These three it's a conventional subject only, but we are tuned for a little bit now. Change the way we learn, then the way what you can say do the evaluation, all those things. A lot of changes occurred in our curricula for adapting to this this fast change. But anyhow, we could simplify the maths. This is our second book, which is will come in now, end of November. Third book is this. So these three, we are hoping that entire gamut of maths record for modern AI can be covered and can be brought down to +2 to first year of engineering or no first year of science. Okay, so not the linear algebra, signal process, and dynamo decomposition for AI and controls. This is our second volume of linear algebra. Other one is optimization. Hope we are able to.
Namaskar, sir.
Yes.
Sir, is there any presentation, sir?
Yes, yes. I have
Yeah,
already
because
shared.
yeah, do you want me to present that? Like I was thinking you are presenting it. Do you want me to share
Yes.
the screen?
Yes, yes.
Yes, sir.
I thought you were.
Sir. Yes.
Okay, so this is the thing. So our first book is this Foundations of Multidisciplinary AI. You're able to see this one now?
Yes, sir.
You're able, okay. So this is available in Amazon. This will be our second book, Optimization and Applications. Okay, this is by December or November, and it will be available or December first week. These three will do. Okay, now we'll come to the problem. Classically, pseudo inverse, which is part of linear algebra. And you can see in a textbook now, you will see only the end of the linear algebra textbook. So usually, undergraduate, I don't know whether anybody anywhere teaches this subject. But anyhow, it is part of linear algebra. So to get the pseudo inverse formula, we have to learn a lot of things. Starting from single value decomposition, you can see here this formula. For this talk now, you don't require any of this one. Just A is ambient matrix. Okay, you just know the concept of rank of a matrix, all those things. So any matrix can be decomposed into these three. U, sigma, and beta, of course, don't worry. But understand one now, this linear algebra, this particular decomposition, you use left and right now, all engineering. Google basically search engine works on this decomposition. And here there is a pseudo inverse. For a matrix M by N, you have now N by N matrix. So pseudo inverse is now applicable for any matrix, irrespective of its rank, and now any matrix you can find out pseudo inverse. So any M by N matrix, it is a rectangular matrix, you have N by N matrix. Okay, and this now, this U, sigma, all those things, you have to get from as now eigenvectors of and corresponding non-zero eigenvalues of A transpose star. So this is the problem with this method. Okay, it requires lot of background material to get the pseudo inverse concept. So that is why it is, I don't know, it is not so far I haven't seen any Indian university syllabus, especially undergraduate level. But once you master this one, you can, especially now current research is moving now, almost all area they are utilizing this. All AI data science move into that area. I will show latest research papers. Okay, now you don't declare this one. Our aim is now avoid this formula, come with a different formula. Okay, the same result. So there is something called CR decomposition of a matrix, column row decomposition of a matrix, which a +2 students can easily do. Okay, then based on that one, now you can find pseudo inverse. Okay, later you'll understand why pseudo inverse is occurred. Okay, time P, you understand? For a square matrix, if it is full rank or determinant is not equal to 0, it has inverse. But pseudo inverse, any matrix, you can have pseudo inverse. The only thing is M by N matrix should be N by M. Understand that much at present. Then you will see once you master, because I have here only 1 hour, so I can't go deep into, but still later I can take. If you probably spend 1 day or 2 days with me, I can teach you entire gamut of AI using this concept alone. Okay. So basic idea is this: through CR decomposition, A equal to CR, I can have pseudo inverse. There is this notation for this dagger sign is the notation for a pseudo inverse. Okay. So this matrix C and R, they can have now something called R can have right inverse, C can have left inverse. Again, don't worry, you are going to see it. Okay. But this formula now +2 students can learn it. You see why +2 students can learn it. See, okay. Now I come to the proper. This is something now. Gaussian row elimination is something you are learning in +1, +2, even high school level. It is there. When you are solving X, it will be okay. Without knowing now, you are actually applying Gaussian elimination. Okay, so consider this matrix now. This is square matrix, but I can take rectangular matrix. Okay, look at column wise now: 1, 1, 2, 2, 1, 1. When 2 columns are added, you can see third column because I purposely built that way. Okay, so this matrix has important property: determinant is 0. You can't find inverse of this matrix. Though it is square matrix, you cannot invert this. Okay, and these numbers, probably you may wondering now, okay, matrix, what these numbers represent. It's actually now when you take data, okay, data, many cases now data will come as a matrix. Okay, most of the cases now your data will be image or whatever. Okay, come as a matrix. So you'll be interpreting in a special way for AI and data science. Okay, now first column 1, 1, 2, second column 2, 1, 1. When you add this one, this one. So this matrix, if you find determinant, it is 0, and you cannot find inverse of this one, but you can have pseudo inverse. Okay, so cross this you have 1, 1, 2. I should make below the first one. Okay, 2, 0, 0, 0, and make. So you will be using first row, multiply with something, add to second row, make 0 here, multiply something, add to third row, should be equal to 0 there. So this process is called Gaussian row elimination. Most of you might have already studied this for solving A is equal to B or inverse. People use this methodology. So I will go a little fast, therefore not fully line by line I'm not explaining. So something like this, you get after 2 operation. Then I'll make all the elements below that main diagonal to 0. So this should be made 0. For that one now, I multiply the second row with something, add to this one. Okay. So this case, before that I can scale it. I will make it 0, 1, 1, -3, -3. Scale means now divide by -1 here, 1, 1. I can divide by -3, it becomes 0, 1, 1. Then you can see these 2 rows are same. So we say in Lie algebra terms, we say 2 rows are now dependent. So 1 row you can eliminate, or you say 0, 1, 1. Then you multiply the -1, add to third row, you will get 0, 0 here. Okay, so this is the first part of your row elimination process. But we will do one more this one process. Okay, this 0, 0, 0 you can row you can remove 1, 2, 3, 0, 1, 1. Basically, it means now out of 3 rows, only 2 are independent. Okay, independent sense now here 1, 2, 3. By multiplying now with something I won't get 0, 1, 1. These 2 rows are now independent. Okay, so one more process we have to do. Okay, 1, 0, 2, 1. So the first non-zero element here is this one. So corresponding column is second row. So this element, I want to make it 0 by multiplying the second row and adding to first row, multiplying this one, then add to this one. Okay, I should make 0 here. So finally, you are getting like this: 1, 0, 0, 1, 1, 1. And this corresponding column here, first column, 1, 0, 0, 1. I call it as pivotal column. All this now, any Lie algebra book you refer, Okay, you can see this row reduced echelon format, that type of thing, Gauss elimination. Okay, so you go through that type of textbook, or take our textbook, and you can we are given so much of detail all this process. It's quite simple. It's not that at present you just, okay, I'll give only an outline. Okay, so we call this as a row reduced echelon format or staircase format. Okay, so we denote this matrix, whatever we finally obtained as now R. Okay, 1 0 1 0 1 1. Okay, so keep ready now. This first two column 1 0 0 1, that now we call it a pivotal column. You go to original matrix. From there, take the first two column, because 1 and 2 are the previous this one column 1 R we have to look at this, and this we call it as pivotal column. Okay, so first non-zero element here, this is the first non-zero element corresponding column. Here first second row, first non-zero element is coming here, corresponding column, we call it as pivotal column. There is no further pivotal column, two columns. So from go to original matrix, take the 1 1 2 2 1 first and 2, you multiply this, you get the original. That is the beauty. So this is now very famous CR decomposition. Old textbook, if you take, it is not available. Okay, so this methodology is now popularized by MIT professor Gilbert Strong. Okay, that too not old book. His latest book only. This methodology is though it is an old goes in elimination process everything. So somehow now only people are understanding this particular decomposition. Okay, after Gilbert Strong put in his not textbook. Otherwise, not textbook, now you will see this C into R decomposition. So you can see now C into R equal to A. Importance of C and R is like this. These two columns of C are independent. Independent in the sense, one column, for example, 2 1 1. By multiplying first column, you can't get 2 1 1. No such number exists. If you multiply with 2 with 1 1 2, you get no 2 2 4. You can, there is a single scalar multiplier, 1 1 multiplying the 1 1 2, you won't get no 2 1 1. So similarly 1 0 1 0 1, they are two independent. So concept of independence is a fundamental thing in linear algebra. So make it thorough. So initially may find difficulty, but it's a fundamental concept. So columns are independent here, rows are independent. When you multiply this one, you get A. So this is now the famous CR decomposition. Okay, don't take any old book and look for this CR decomposition. It is not there. Okay, now very important thing, A equal to CR now. Okay, first part is over. So this C has something called now left inverse. That is the important thing. Okay, left inverse for this. We are going to explain that one. And this R has right inverse, meaning for this matrix C, left hand side I multiply with a 3 by 2 matrix, I can get identity matrix. This is R. Right hand side I multiply with a these two 3 by 2 matrix. Okay, I can get a identity matrix. So we say column C has left inverse, row sorry, not column C matrix has left inverse, row matrix R 1 0 1 we can call it as R, it has right inverse. So anyhow, compute C transpose C and compute now RR transpose. Okay, we'll get a square matrix. C transpose C. So this is your C. This is C transpose. Multiply, you'll get a 2 by 2 matrix, which is invertible. This matrix will be definitely invertible because these two columns are independent. So there is a linear algebra theorem. This is invertible. Okay, C transpose inverse is this much. And R transpose. This is R. Okay, R is here, R transpose is here. Again, you get a 2 by 2 matrix, which is invertible. Okay, you can get this one. Okay, then you got C transpose inverse. C transpose inverse, you multiply the C transpose. There is a specialty this one. C transpose inverse, C transpose. Again into C now. Suppose I am putting C here. It will be identity matrix. Now C transpose C inverse C transpose is actually what is called left inverse of this matrix. Okay, you get this one. It is a 2 by 3 matrix. This is 3 by 2. Just 2, 3 by 2, 2 by 3. It will be 2 by 3. You can see here now a 2 by 3 matrix. When you multiply this with this, it will be 2 by 2 identity matrix. So this is C transpose C inverse C transpose. Okay. Now come to next one. Anyhow, you can verify this one C into CL inverse. I call this as left inverse of the C matrix. Okay, so left inverse of C, you are represented as now CL inverse. Now CL inverse into C, you can see it as an identity matrix. That's why it is called left inverse. You have C matrix and you have a CL inverse, which is basically this one. So to a C matrix, this I call it as a column matrix. You have this one. Column matrix I can tell you because these columns are independent. Okay, so you can identify matrix. Okay, now come to R. You have I multiply here now R transpose inverse, R transpose into R transpose inverse I am finding. And I denote this quantity as now R's right inverse, RRT inverse 1 by this one. Okay, so importance of this one is R into R, this will be anti-matrix. Okay, this is the basic thing. Okay, A equal to CR, this C has a left inverse, the left inverse is this one. C's left inverse is this one. R has a right inverse, see the dimension changes. This is 2 by 3, it will be 3 by 2. So this is my, okay, R's right inverse into C's left inverse. Okay, you get a matrix. This matrix is now is what is called pseudo inverse. Okay, which previously people were obtaining in a totally different procedure. Eigenvalue, eigenvector, A transpose corresponding, take now, then lot of theory is behind now, or steps are required for conventional way of getting pseudo inverse. So this is something now for small matrices. Okay, plus 2 students can easily do, at least now, though they are not understanding the full why it is done, all those things, manually they can do. Whereas conventional pseudo inverse, even manually doing is extremely tough. Okay, so this matrix, but I don't know this one. So A equal to CR, then R's right inverse, C's left inverse. You multiply what is that is called pseudo inverse. So from here I am starting. Slowly understand now why pseudo inverse is where it is applied. But okay, okay. So if you want to understand the full theory behind pseudo inverse, you have to read our book or Strang's book, which costs around 5,000 rupees. But I think this some of the latest book, old books are downloadable, but this CR inverse, CR decomposition only latest book is available. Okay, anyhow, so this is pseudo inverse. Okay, and we can do for any matrix. Some example symmetry matrix I'm taking. Here again, now rank is 2. Okay, this matrix, A matrix don't have inverse. I can do like this, determinant equals 0. There is no inverse for this one, but it has pseudo inverse. Okay, same procedure I'll take, and finally you will get pseudo inverse. So pseudo inverse you are getting like this. But now any matrix, this is just to show rectangular matrix I am taking, but this is now 2 by 4. For 2 by 4, I will have now a 4 by 2 matrix as a pseudo inverse. So this is 2 by 4, 2 rows are independent. Okay, so this has a pseudo inverse, but now later we'll show, or we can show it is basically right inverse of this matrix itself is pseudo inverse. Okay, so when you row elimination process, you are converting into C into R. So don't worry about this one. Just remember that there is a row elimination process. Okay, which make them two vector row vectors in a special format. Once you understand that one, okay, you can make the, okay, this basically now it is easy to interpret actually. Here this tells that here first column and the third column, first and third column are independent. 2 4 is just multiply 1 2. Okay, so that actually now this tells that one first column and third column are independent, others are dependent on this first and third. Okay, so 1 2 1 3, then this matrix 1 2, sorry, this when you multiply this one you will get this. Okay, so simple interpretation is possible. Since lack of time I am not so this is any matrix we can do like this. Okay, now finally your inverse for that matrix, for example A equal to CR. So this is 2 by 4. Here now you have 4 by 2. Okay, and in this particular case now A into its pseudo inverse will be identity matrix. Okay, but 2 by 2, not 4 by 4 only. Okay, so this is 2 by 4, this 4 by 2. So when you multiply A into pseudo inverse, A into its right inverse, actually it called as pseudo inverse now. Basically, it's right inverse. It's this matrix right inverse only. you get okay, a matrix. So A into A pseudo inverse, you can see it is equal to identity matrix. If I multiply this one, it identity matrix. Okay, so this is the introduction to pseudo inverse. Now I am going for now actual machine learning problem where it is applicable. Okay, you are going to see now entire classification, regression, everywhere you can apply this particular concept. Okay, for example, now starting with a very simple machine learning problem. Old 1980s people started something called decision tree. Okay, they took that time now this type of simple example. Okay, you had two types of insects, okay, grasshopper and katydid. Okay, you want to come with a rule for classifying these two. Okay, so you are measuring now. These are the measurable features. We call it as features. But I'm taking only two features here. Okay, this two feature now. So this katydid and say grasshopper almost look same, but when you actually make measurement, you can see there is okay a lot of difference. Look not that much, but actually when you measure, you can. So basically, what is happening in machine learning is something but geometry, simple geometry only. So if you plot these two features, you can take this as x and y coordinate, abdomen length and antenna length as now the x and y features. Then is all the okay grasshopper is coming here and katydids are coming here. So naturally you can have a okay something like now you can draw a box, and based on this box you can okay make a something called no decision tree. Very famous 1980s machine learning started with the decision tree only. Decision tree clustering, that time no regression, that time is there. So that time classification, almost everything was done using decision tree, 1980s. Then came other statistical methods, supported machines, neural network, and all those things. People start applying. Okay, so this type, because easy interpretable. So this, this grasshopper is coming here and katydid come here. So you can see the addition tree coming here. So, but now we are going to use pseudo inverse for this application. Okay, because this is old this one. A two variable thing you can easily plot and see, but if you have 100 variables, no question of plotting and seeing now whether it is how to find out decision tree. It's not that easy. Okay, so these are decision for say medical data. Okay, gender, age, BP, drug assigned. They have 12 data. Okay, so decision tree look like this. This problem also now I can easily tackle with the, or we can easily tackle with the okay pseudo inverse. Okay, but now the way you are doing sort of different. This is easily interpretable. Okay, based on inside BP is high, drug A, BP is low, drug B, BP is normal. Okay, BP is normal now both A and B are given. So if BP is normal and if age is less than 40, drug A this one. So like that, this one now we can make a decision tree. This also we can easily replace with the single method. Okay, now what you are going to do is we are going to go for regression, something which are learning in first year. Okay, this can be easily taught to +2 students. That's why we are proposing entire deep learning should be given to +2 students, slightly modify their matrix algebra and coordinate geometry. Okay, if that is slightly changed and put together, okay, entire deep learning can be taught to okay +2 students. It should not be now. You should learn all these things. My new generation now should learn all the deep learning things right in +2 by first year of your course. Whatever be the course, can be maths, physics, chemistry, biology. You name everything. First year now deep learning can be over. Okay, so that is our aim. Okay, come to regression. Basically, regression is about now fitting a equation. Okay, fitting a function. But now here now is a linear regression. Therefore, we are fitting y equal to mx plus format. You have some data 1 1. This is 1 1. This point is 2 1. This point is 2 2, and this point is 3 2. So I have 4 data points. Plot it. Okay. This is now what is finally coming as feature. Previous is one now your x is a feature, y is a feature. Plot like this. So in this case, okay. Regression case we call y as dependent variable, x as an independent variable. Okay, we are going to use this for classification task. Regression mean now somehow relate x and y, linearly relate. So when you put into mass framework, okay, you are find out now an approximate line for this. Can't pass through this line, can't pass through all the points. So a best fitting line you require. Okay, so the process is called regression. You have to find out now slope and intercept. MNCR, slope and intercept. So take the first point. Okay, its x coordinate is 1. Okay, y coordinate is 1. Y coordinate I will be writing here. Okay, so mx plus c, m into x, m into 1, c into 1. Okay, must be approximately equal to 1. Second is this 2, m into 2 plus c into 1 is should be equal to 1. Okay, so don't so you get to know here now what 1 1 1 1 has come because it is not y. Y is here only. This x, this is y, and this is because of when you are fitting y m plus c. Okay, correspond to c, 1 1 is coming here. Okay, so this one. Now I want to find out MNC. Now beauty this one now. You can derive multiple way. MNC you can find out using this matrix now pseudo inverse. MNC equal to this matrix pseudo inverse into this one. Just like X is equal to B. Okay, if A is a square matrix, X is a vector, X equal to B. If you are solving, usually if it is invertible, use X is equal to A inverse. Same thing is coming here. So instead of this matrix is a rectangular matrix. Conventionally it has no inverse, but it has pseudo inverse. So MC equal to pseudo inverse of this into this Y. That is what you are going to do. Okay. So finally, you are getting that one. Actually, you are finding now left inverse. There is a formula for that one. Or this matrix has a very important property. This has already 2 columns are independent. It has left inverse. Its left inverse itself is its pseudo inverse. Okay, and you multiply that with the right hand side, you get an MNC. Okay, that is what is happening. Okay, so you get to know MNC as now 0.5, 0.5. Okay, so this type of things now can be taught to +2 students. Okay, I'm going a little fast, may not be, but later understand we go through a little bit time. Okay, it is not that tough. Okay, you get MNC. So once you get MNC, you substitute back what you are getting. Once you get MNC now, when you substitute back, this is your A, this one, you are getting 1, 1.5, 1.52. But now you are supposed to get 1122. But they are, because my line is this line not passing all the points, but you take the difference. Okay, we call it as error vector. Okay, y is the your 1122, yc is now y predicted for every x. Okay, there is a y. This is the y predicted. Okay, take the difference now. You get something called error vector. This error vector has a very important property. This is all part of linear algebra. So you should be extremely good in linear algebra. Then now, once you made that one in the first semester, machine learning, deep learning, and data science, all will, you can say, you can conquer now 2 weeks, 3 weeks, not more than that. But your linear algebra optimization theory, especially linear algebra. So this is your error vector. Okay, you take, multiply this one. We call it a dot product. Dot product is 0. That means now error vector is orthogonal to first column. This error vector is orthogonal to second column. Dot product is equal to 0. So you can get this one. It's just telling now this relation, because that type of things are very important. Okay. Now from regression to I'm going for classification. So now you see now this regression now we can modify for classification. So see here, I have now 2 class now, red points and this one. And I have class label now for applying this pattern classification, this one, or now converting regression to classification. I represent class label as, instead of 1 and 2, we put as something called one-hot representation. So red point, my class label is 1 0 0 1, this one. For this one set of points, I put as now 0 1 0 1 0 1. We call one-hot representation. So now you have 100 class, you can represent. Okay. Then you are these 3 points now. This the coordinates. These 3 points. These are the coordinates. Okay. So you are basically what you are trying to find out a set of weights. In this case, since your y is 2 column, your w or unknown now this one has 2 column. This is only a difference. But otherwise, this is ordinary linear regression only. So linear regression you are going to use for classification. Okay. So this unknown weight, just like in a neural talk, you have weights. So here, 2 column, 2y, therefore 2 this one. Then this is now again you find out using pseudo inverse of A into this matrix. You will get now this weight matrix. But now you can give only approximate, because cannot pass through all the. So if you apply now pseudo inverse of this left matrix A and multiply to this one, first we find what is now this is 6 by 2. So your pseudo inverse will be 2 by 6. Okay. So your this okay. So I'm showing here. I'm calculating A now. A is now Latin inverse into Y. We are getting now W as W is the weight matrix. Minus 1 by 3, 1 by 3, 1 by 3 into minus 1 by 3. Okay, this column, this column. Of course, now you're here, this one. And directly writing there. You can directly compute this one and get it. Then you substitute back now into A into W, W multiply. Now you are not getting exactly equal to the class label you wanted because it is regression. You won't expect now same Y value to be obtained. It will be always approximate. But very important, you can note that one. Okay, previous one, class label here now this high, this low, this is low, this is high. But at least that relation we can see here. Here now, this one. So this is high here for this one, high here. You replace with 1 0. And here now you replace with the 0 and 1. All this. Okay. We can use that for classification task. Okay. So like this. In each row, we replace the highest value to 1 and the other by 0. So what I mean is this is here now 2 number here. So when you take 1 by 3 minus 1 by 3, this is high. So put 1 here, 0 here. Okay. So regression now we are converting into classification task. This is the way. You don't expect now same whatever you given a Y value or to obtain approximate, and from that one you make the rule. Okay, this one. So you are learned now a set of weights. Okay, W. And if you give now a point around this one and a point around this value now, you can use this matrix now. Okay, it approximately map to. Okay, it is class 1. Okay, first number will be high, second number will be low. If it is belong to near somewhere here, near you are giving. Okay, and some S can Y multiply this one. Now you can see now Y side will be coming as now. Either 2 number will get. So is the biggest number coming in the first position means is class label 1. Biggest number out of that 2 coming the this side will come as. So that is the basic idea. So we say now we are learned the weight. Okay, this is called what you basically called as machine learning now. Finding this W, you machine learned. Given data, this one approximately classified. Okay, so you make a rule there based on this one. So this type of thing now you can use for all the conventional data sets. But there is a problem. There are data sets, very complex type of data sets are available. I will tell you some of the data set. Okay, let me say here like this. Okay, 2 class. Okay, this is not 2 spiral. This is checkerboard data. Okay, so we say now this type of data set not linearly separable. Okay, that case now we have to do some additional task. There are so many methods. So I am telling you one method which I call random Fourier features. Don't worry, but there is a theory based on basically probability theory and Fourier series. But don't worry, we are mapping to high dimension. Okay, so finally, okay, it is going like this. Okay, before that now, if linearly separable data you have, suppose you have now 3 class problem. Okay, your data, row are your data, your class label. Okay, then you have your W to find out. So pseudo inverse you can use if this is linearly separable. Linearly separable data look like this, 2-dimensional case. So there using W now, you can find W or this W matrix. You can easily find out. Then when new data comes now, so here you put data here, multiply this W, you will get a 3 number right hand side. Okay, and you find out now which location that number is high. And based on that one, you say, oh, this class 1, class 2, class 3, etc. That is the basic idea. It is so simple. Multivariate Gaussian. Okay. Now we are going for this the actual this one. You have first data. This is the class label. Second data, class label, 1/4 representation extra. And this weight matrix we have to find out. Okay. So for separable data, linearly separable. Only thing is now when data dimension, number of features are very high, you won't be able to plot and see whether it is separable or not. Okay, so anyhow, simple cases. If you assume that one now data is linearly separable, this weight matrix we have to find out. Just nothing but now your data is pseudo inverse into class label. You get this approximately this weight matrix. It approximately map. Then 1/4 representation. Whichever location when a new data comes, the data put here weight matrix, you will get that many some numbers. So here I'm assuming now k number, okay, k classes. So whichever location, first location, second, third location, number is high, that location is your class label. That type of thing we can do. Okay, now suppose data is not really separable. There is a problem. Like this type of data, what you will do? A very simple idea. So this, what I call as random inference algorithm, proposed in 2007 and 2018 or 19 got now as the Testo Time Award, one of the best algorithm invented for in machine learning. Okay, only thing is now this type of things you can't see in any ordinary textbooks. Okay, because learning neural network and everything now people take it as a black box. So somewhat people can little bit Python toolbox and everything you can do something. But when you come to here, you should know the whole math thoroughly. Okay, anyhow, this algorithm got Testo Time Award. Okay, sort of a Turing test type of award, best paper. Because now people applied left and right for various applications. So idea is this: when this data is not linearly separable, so I have two tuple data. If I plot one case is like this, another case is like this, third case is like this. Okay, so these are two columns. That case, what we are doing now, you are mapping to higher dimension, meaning two tuple data you are mapping to. So in this case now, some 45 dimension. So two number, based on this two number. So here now I have something called this basically random numbers for a normal distribution. Okay, then this first two number into this matrix will become now a 45 number. So we say now you mapped a two tuple data to 45 dimensional space. Okay, so second data is second row will come here. Third data, this is basically random numbers from normal 0-1 distribution. Okay, only thing is now when new data comes, this matrix should be ready there. You cannot throw it away, this matrix. Okay, because mapping this one. Once mapping, first now two tuple to I am taking a 45 tuple dimension mapping. One more operation is required. After mapping this one, now I take okay, cos or sine. In this case, now I am taking cos 45 number, and same this one. Now each element I take sine. Okay, so don't worry about this one. There's a big theory. This it is called random inference algorithm. So basically, what you have done now, your two tuple you have mapped to 90 dimension, and here now it will be linearly separable. Only thing is when your new data comes, your weight should be initial. This random number here, same random number you are supposed to use. Don't use any other this one. So this weight is stored, mapped to initially 45. Then each element you take cos, each element you take sine. Okay, this is how you are data creating. When you do new data comes also, you have to do the same process. Very famous algorithm. Okay, and then you can use for now regression. So data map to high dimension, apply the same regression methodology. Nothing. But now almost classical any data you take, this methodology will work. This is such a wonderful algorithm. I mean classical data set means features are available. Features available now, all this because here now X and Y are readily available, or your problem here, this classification here, features are available. But there are situations where no features won't be available. There only now you are applying this convolutional neural technique, automatic feature abstraction. Okay, features already available means this can do the task. You need to know only pseudo inverse, nothing else. Okay, so that level we have reduced the task. Okay, now there is something called neural tangent kernel. You can search internet, introduced in 2018. Okay, so basically what they are doing is this is a neural network structure. This A and B, both A and B can say this are learning. I'm not going into detail of this one, but this also now you finally tackled using this pseudo inverse. Only thing is now some based on Taylor series expansion. So basically what happens is now X here. This truth in this B matrix map to higher dimension. After mapping to higher dimension, you take sine or cos nonlinear function. Okay, and this A, of course, this A you can this also you have to find out in this case. Okay, you learn through when algorithm. I'm not going to. The algorithm is called neural tangent kernel. Okay, but here also now you can apply pseudo inverse, especially this portion. If you are learning this one, this portion you can easily apply a portion now. You apply pseudo inverse for finding it. So don't worry. Don't worry about this portion. Now I'm moving to today's last portion. So up to here, what I actually up to here, what I told now. you map to your data, linearly separable. It is so linearly separable. Directly, you can find the weight. You can find the weight and find pseudo inverse. Based on that one, you can get the class label. New data point comes, use that inverse. It is not linearly separable, map to high dimension. And one of the very powerful methodology, we call it as now in subtractor machines type algorithm, canal method. Okay, this actually theory of this mapping to high dimension come from there only, but there is a very specific type of transformation here. Okay, why we call it as Fourier and all those things at present I can't tell. Okay, but I have our book now. It is fully explained. Okay, why it is called random kitchen sink algorithm or no random where the Fourier come into picture. Okay, it's theory. No, there is a Fourier actually, but you are not seeing Fourier anywhere. You are seeing only random numbers from normal distribution. This matrix you are generating and then making into a dimension. Then you go for regression. So extremely complex problem. Now you can solve this matter. Now I come to one more problem. Okay, modern this one. So I have done now regression and classification. Okay, other problem people now are dealing now is generative AI. Okay, given a one kind of data, somehow it should learn. Then now it should be able to produce new data from that category. Okay, so now there is an algorithm. This is a latest paper actually. Of course, idea is the right from 1995, but now only people are really identified its use. Okay, there is some pseudo inverse learning algorithm for variational autoencoder. Okay, variational autoencoder is a methodology for generating data from given set of you given for example you have given cats now 1,000 cats you have given different now you learn something what we call a representation of all this 1,000 this one using that one. Okay, basically you will be generating random number finally random numbers from a small Latin space. Okay, and using some extra type of keywords anyhow. So from random number after learning, okay, I'll be starting from random numbers only. Finally, I'll get a cat's picture. Okay, but this time it will be totally different from whatever you are given. Okay, you can have now so many variations. So the methodology is called variational autoencoders. Okay, so its architecture somewhat now look like this. Okay, somewhat advanced machine learning. Okay, because now people are using AI for generating. Okay, you give text to generate and runs images. Okay, so that type of thing. So what is the basic behind that one? So the theory started with now autoencoders, then various autoencoders. Okay, so idea is this. So here now you can see I already given the latest research paper. Okay, computation and web propagation free pseudo inverse learning for neural networks competency survey December, because it is just to come only, but it is still available in internet. Okay, from here only I taken, and now I simply be simplified finally applied now pseudo inverse only. Can we build a generative model without web propagation? Okay, that is this is already okay. So here this I already shared with your madam. So madam will give the slides, and when you click here now you can get the data and all those things. Okay, coming based on a latest research paper. Okay, this is 2024 paper. Can we build that data? So this also now we can easily deal with the pseudo inverse. Okay, I'll give a brief idea because I am not sure whether you have encountered various autoencoder type of thing generation. Okay, there are two. In addition, various autoencoder. Other theory is basically diffusion models. Okay, this also some of the latest thing. Now all this can be dealt now with a simple linear algebra. This is now published only two days back. Daily diffusion, this one unfolding generative flows, the Koopman operators. It's basically linear algebra only. 2 days back only it is published. Okay, without a neural network, we can deal everything. Almost all deep learning can be dealt, except our large language model. That also Actually, we can deal with without a neural network, but I require a separate class for that one. So I coming back. So just quickly, I will tell this the okay latest papers and all those things. Code is available here. Now here, no problem is this one. I have now this is MNIST fashion data, fashion MNIST. Okay, this is one class. There will be similarly 10 classes of data is given. Okay, 70,000 data, 28 by 28 size with the 10 labels. I have taken now one label. So this is actually reproduced one. So from this label one class, one type of shirt, okay, you learn something. Then from starting from a set of random number, which you are using as 8 random number, you will be generating this one. So you have to learn that one. So I'll tell now what is the concept of now latent space. Idea is this one. You have 784 by 2000. I have taken a 2000 shared data. Okay. Then vectorizing it. Vectorized with now it is 20 by 28. So 784. So this is your first data, second data, like that now 2000 data. Okay. 2000 shared I have taken. Okay. 28 by 20 matrix. Okay. Like this. Okay. So since this size is 784 in the neural tech now, but now you are not actually using neural tech data training. Only architecture is that way, architecture. So 784 neurons, this weight. Okay. And here this weight now you are taking random numbers. There is a beauty normal 0 now. This many is the D. Here I am taking as in this case 2000 itself. This 2000 is number of datas. But now in this particular case now, in general you can have D. Okay, but now in the example given now, I'm taking this D itself as 2000. Okay, so this data goes through this neural network, then go that way. Okay, apply a nonlinear operation. Okay, so your data when it reaches this side, okay, come like this. H1 means hidden layer, it can say output. So note this one, 2000 data you are giving. Then you get now another 2000 here now after going through this one. Dimension has changed. Then one more this one. Okay, you get here. Then you are doing a very special process. Some now using another W3. You reduce the dimension. Dimension are reduced into 8 only. Okay, dimension reduced to 8. So this is what I call now latent space. Okay, so your data is 784. I'm reducing to 8. Okay, 2000 this one. Okay, then there is a reverse process here. I can say this. I'm taking 2000, 2000. Here also 2000, 2000. Like this. Finally, now in here I'll get to 784. So neural tech architecture only, but entire computation is without propagation. You require only linear algebra, nothing else. Pseudo inverse only finally I'll be using. Okay. So this is the latest thing. It came only last year, but given time, this and out now, you can't get the full details within 1 hour. But I'm telling with the pseudo inverse alone, okay, this variational autoencoder you can learn. Okay, and it gives now state of the result, whatever conventional various autoencoder gives, which started now, theory started in 2020s only. Okay, various autoencoder. Okay, first thing came around 2000, I think 12, 13. Then most of the theory came after 2019, 20 only. So anyhow, that theory now simplified like anything. Only thing is here, this latent space and everything will take some time to understand. Okay. So anyhow, this is the architecture. Okay. So finally now using your data, you will be finding weight here, this pseudo numbers only, this using, sorry, random numbers only. This I will be using pseudo inverse of whatever data come here. I'll find the pseudo inverse and put it here as a weight. Okay. Then nonlinear operation like that. So I'm not going to details here. I'm only telling, okay, the whole process you can do the pseudo inverse. Only thing is, main thing is now we have to find out the W3, W4, W5, and W extra. Okay, I'm not using neural tech at all, but there is a way of finding all these weights. Once the weight is everything is obtained for your data, then you can throw away this encoder part. And here now you will be generating for normal distribution 8 number, pass through W4, reaches here, pass through W5, pass through W6. You get now 784 number here. You reshape and you'll see your output will be okay looking like this. So whole process is here because lack of time I'm not fully explaining. Okay, there is, but now W1 is a random weight. Okay, then W1 into X is your full data. You apply nonlinear operation. Here usually ReLU type of nonlinear is only people are taking. Okay, then W weight, now this H1 what you are obtaining here. H1 here is actually output of this one. Use simply pseudo inverse. That pseudo inverse become weight here. Okay, that way of proceeding. And W3 and W4 alone, little bit extra probability theory is required, but now it is simple only because of 1 hour I can't fully explain. That's why leaving here how it is obtained. Okay, so finally, I am using only the whole thing using only pseudo inverse alone, nothing else. And there is no neural type of learning going forward, backward. No, 2000 data is there. Neural tech now you have to give the first data, go forward. Then say second data, go forward. Then come and change the weight. Now and now 1000 times you repeat, find the weights. Here nothing. You give your full data. Okay, one stretch, 4 line now at maximum 10 line of code. You will be finding all these weights. Okay, once weight is over, here, this encoder part you can omit. Here I'll be randomly generating 8 number. It is my latent space. Okay, this one. And using W4, W5, W6 now, I can get back this 784 number. You reshape to a 20 by 8 matrix, you will get now. So for each class, you can do it. Each class of this should run this one. So whole process not fully explained, but still the computation now coming like this. Then generation part. Okay, in between now some linear algebra proportion is there. I'm omitting this one, but I am telling some 20 lines of code, full mass without neural tech at all. But you can produce no state-of-the-art results. Okay, this is just tell you what is possible. Now, once this thing now, once you understand regression now, these are the thing you can do. Linear regression, nonlinear, linear classification. A lot of things we can do. Okay, and if you want now, there is a website actually for this MIT. 7 lectures now I finish under modern machine learning. Okay, but now he is using conventional pseudo inverse. What we did it now, we took idea from this person. He's a professor in Stanford and MIT. Okay, 7 lectures. Everything now we can do with the pseudo inverse. That is what we had done actually. We brought down the mass to +2 level. Of course, some cases now first year engineering level. This is what I have done. Okay, so from here only we have taken. But before that, I have some more. This one. So our next book now we are bringing this one. This is now this paper came only 2 days back. Everything can be put into linear algebra framework. Unfolding generative flow and Koopman operators, entire control system, entire I think say deep learning. Most of the generative type of now deep learning, okay, can be put using or put under now linear algebra now. Okay, so our latest book, basically we want now first year itself, whether it is BTech, MTech, I can say BTech, no, sorry, BTech or BSc, anything. First semester itself now, entire deep learning can be taught. Okay, so that is at least our claim. Okay, so this is from latest research paper. This I have sent to your faculty. Okay, that's all. So what I want to tell now, of course, this is an only outline. If you learn, if you give me now, for example, all of you come here now, this our Timade campus today. In 2 days, I'm 100% sure. Okay, through this one now, entire deep learning can be taught using one single concept. Okay, pseudo inverse. So that is at least our claim. Okay, and this books, coming books now, 3 books. Okay, the first book is already available. Other one within 2 months it will be coming. Okay, so if you are buying that one and or need not buy, but if you come here for 2 days, we can teach, I can say, all these methods. You require only one concept, pseudo inverse. And if you know a little bit more about optimization theory and probability theory, ultimate. Everything can be learned in probably 1 or 2 weeks. Okay, so this is a gist of what I want to tell. Okay, back to, I don't know how much time I took. It's only over. Okay, back to, hello?
Yes, sir. The floor
Okay.
is open for a small questionnaire session. If any students are having some doubts, you can raise your hands.
Sir, actually, this happens to be the first session for us, and you had actually shown one slide where you had been conducting classes from June. Is that correct?
Conducting classes
From June. There was an image actually. Your image. Could you please go to that slide? Yeah, this one.
Oh, this
Yes.
one. Okay, this is
Yes.
not my this one. MIT's course.
Oh, okay.
This MIT's microprudential course, which
Okay.
from where now we took the idea that now pseudo inverse can be utilized for entire machine learning. Okay, but problem now he used conventional pseudo inverse. We used a new pseudo inverse to bring down to +2 level. Yes, this is now if you want know this, you can get download from internet. It is available.
All right. Thank you for the clarification. Yes, sure.
Hello.
Yes, yes. Tell me.
Sir, I want to ask. Actually, all this webinar was all about. This is a part of BCA, or it's not the part of BCA.
This is now I'm taking a class. Okay, on there are some simplified method which can go to school level. Okay, so all data science. If you learn basic linear algebra, entire data science can be taught. Okay, so here deep learning portion. Now I am telling using pseudo inverse we can learn everything. My suggestion to you is now never learn anything for examination. Course everything is project based. Like here in Coimbatore. Okay, so,
No, so
some tests are there.
Okay, this was not a part of the lecture.
Actually, this is a webinar session. This is not a live session or your weekly session. This is a webinar. Sir was trying to help you with a topic, and this is not a live session. So please consider it as a webinar. And if you are having any doubts regarding the topic he was taking, you can ask the questions.
Hello, sir.
Yes.
Yes, sir. I actually wanted to learn about deep learning and go further. So, what basics should I? You told you should know linear algebra, linear regressions, and stuff.
Yes.
So, what all should we cover from the basics so that we can come and learn from you guys?
Yes, only linear algebra. First thing, because most of things can be covered using linear algebra alone, say 90%. Then if you want to go further and now do really on fundamental thing, then you should know little higher level optimization theory and little bit probability theory. Okay, and what we are now trying to do is all in the future now everybody is supposed to learn deep learning or no this AI. Nobody, irrespective of the branch, whether it is you are a BSc biology, chemistry, or no arts, I didn't say economics. If you don't learn AI, you are nowhere. Okay, at least you should know how to use the tool. So, seeing that seeing this situation, what we have done is we brought down the maths to +2 level, so that entire thing what I taught I can give to +2 level students. So when they come to engineering or whatever, even medicine is changing like anything. Without this one here MBBS is 0. Here engineering is also okay. Without AI put into every subject, that is not going to students they are not going to get job. So since it is that much important, what we have done is scenarios for that only. There are very simple mathematical technique through which you can learn everything. World is actually simplifying everything now. That's why I showed our latest paper which has come only 2 days back. That require only linear algebra, nothing else.
So
Otherwise,
actually, the problem is it's been a long time since we have studied that +2 and all those concepts, matrix concepts, and we don't remember those stuffs anymore right now. So it's all confusing for us.
No, nothing is that Okay, you are learning. You are learning AI or data science. AI data science you are learning.
Yes, sir.
Yours
not
is BCMCA.
No, I'm currently into MBA AI. So for me, this will be. I want to actually learn deep learning and stuff. So I'm
Ah.
interested also. So
Yes, yes.
should I go back and learn all the +2 basic concepts and then start from the scratch?
Yes, if you want to learn how it works, you learn this one. If you want only a user, but user no, you are as good as a kindergarten student because they also learn how to use that inside tool. Okay, so you wouldn't get any advantage. If you want to really get advantage, you should know the math behind it. So there are two
Yes.
ways of using AI. One, you be only a user. That don't require any degree at all.
Mm-hmm.
Okay, this can be taught to any tool now can be taught to kindergarten, right from kindergarten students. That is what now China is doing. Initially, they are teaching tools only. Then they come to coding and now maths. By 10th standard now, they are teaching almost everything.
Yes.
Okay, so
So
since you are MBA, extremely, because now we have a lot of almost everywhere you can apply this same maths.
yes.
Okay,
So for us, we should go back and learn stuffs, right?
yes, yes. No,
Yes. And probably
uh,
we'll also one day come up to you to ask for your guidance.
yes, sir. Say all of you come for 2 days, you will finish everything. Look, we are now because ours is AI data science now BTech. First semester itself now we are covering everything.
Oh,
This
okay.
book what I have shown now it is in first semester, and we are going for open book test only because no question by hunting anything. Because now world is now your entire whatever is available in knowledge is with the ChatGPT now. You ask it, it will give. Then why you should by heart? It's no question. But now question is no understanding. Okay, so we tell students you don't by heart anything. Don't learn for examination. Every exam now we are to not going to know open book only now. Once these books comes, especially every test will be open book. They did not by heart anything. Understand the concepts, apply, then innovate. For that only now a real value, not for mug up something and writing some examination. Don't ever learn for writing examination. That's my advice. Especially this now age of AI. Everything is available internet. Why you should by heart? So
Yes, sir.
learning
Thank you.
for understanding. Yes. Okay.
Good evening, sir.
Yes.
The
Yes.
thing is that you have actually applied a ReLU, that is linear, that is a neural networks, that is rectified linear units, right? So those functions we have actually we have seen in Python. That is the code where we just apply it, but the max part of it was not explained over here. So are you expecting us to actually learn everything?
Yeah,
And
I haven't. Okay, this up to you. I am telling.
Yeah,
If you are using Python, now everything is available, but that is a
yeah, that's
black
what.
box. There
Yes.
are no any XYZ. You need not be a I can say BC at all. I can teach now train tool to I can say SLC students. They will do as good as now like you. They will also do because it is a I can say importing something and writing some now 5 statements, which now you ask ChatGPT. ChatGPT also will give, but now you won't understand anything behind it.
Yes.
Okay, in this case, entire maths you can start coding because linear algebra now every I didn't say language now linear algebra is there now, PyTorch or now all the Python and
Yes.
MATLAB. Then every language has linear algebra I didn't say built in. So
Yes.
you can based on that maths now you can start coding. You don't depend upon a package. The moment you package, especially Python, you will never understand what is going behind.
Okay, but the thing is that what I'm trying to ask is like, does this come as a part of PhD, or does this come as a part of MCA or post graduation? That is, we
This
can
I
produce.
tell you it is come as +2 because we are
It's
pushing
coming as
this
plus
to
two.
+2 because now +2 maths is enough for most of things.
Yeah. Thank you.
Good evening, sir.
Hmm.
I'd like to ask, since you did mention that you're encouraging, or at least trying to encourage, this thing to be taught to +2 students, could you at least, briefly could explain like what challenges have you faced so far to at least pushing this uh, idea of teaching this topic to +2 students? Like, have you faced any challenges to encourage this idea to regulators or something?
I tell you, we have now BTech first year student this time. Okay, now only we simplified to this level. So BTech first year students, when they come, they are +2 only, just passed out. Okay, so difficulty we faced is, for example, metrics. For them, it is a array of number. But now we are forced into visualize as now either row vectors or column vectors. So there is something called now vector space concepts. Okay, so there initially we faced difficulty. We told them never by heart anything. What matters is visualization, vector space, extra. For +2 level, when they learn something now, they simply by hearted everything. They don't have any idea about now what matters is.
ये वेबिनार जरा क्लास में है कोई है बट द
Okay, so that is the difficulty we faced. So, but now after 2 weeks, all of them. Now I am talking to some of the schools. Okay, so we gave the book and everything, and then we told them, when you just finish your +2, come back. Okay, in 1 week we will teach you all these things. Any question further?
Yes, sir. Could you please share us the blog or a place where we can actually find out the latest theories or latest things that you shared, right? You actually happened to share
I already
one just 2
shared
years
here.
back.
Yes.
Yes, but which source we can actually find out whether there are latest advancements in this field of deep learning or generative AI?
Okay. Okay. Of course, ChatGPT can ask, but now as a researcher, I know now who are the top people in terms of working in this area. Okay. So we always look at, for example, now Harvard, Stanford, India, certain now we know from where this best of the papers are coming. We always look at that one. So I have a collection of now all those, some of those people who are given now foundation for this area. So you always look at that site. Then random search only. After that, random search. For example, I wanted to bring everything into linear algebra level. For example, this various autoencoder. You search internet. Okay,
Yes.
unless
Thank
you
you.
learn very advanced probability theory, you can know this one. So okay, various encoder. Then I will give linear algebra. What is the latest paper? I get that one. Then simplify it, reduce to I didn't say simplify everything.
Yes.
Then we write note, then give to students. That is what we do actually.
Thank you very much. It was very inspiring. Thank you very much.
Will this reduce all the hidden layers in the entire?
I understand. Here, there is no neural network here. Neural network structure only. Neural network now, you have to go forward, backward, and a million iteration. You don't have to do anything. Okay, neural network structure, but your neural network weights. Okay, using simple computation. In conventional now, we call it backpropagation. Okay, give one data, you can't give everything together. One data, go forward, okay, come back, okay, then adjust the weight till now correspond to your input, you get the output. This is a blind, almost blind process. Though there is a gradient-based method, we say, okay, extremely time consuming, and you can parallelize it. But here, you are not doing any such computation. Linear algebra, there is one pseudo inverse. Okay, matrix multiplication pseudo inverse. I am not using anything else in this. Of course,
So
it is not my methodology.
The weight adjustment is completely eliminated. It would be a straightforward, less computational
yes.
pseudo. Okay, so yeah, now I understand.
Everything.
Okay.
So there is no backpropagation. Everything is without any backpropagation. That is extremely time-consuming task.
Yeah, other than the textbook that you have published, are you providing any online course, sir?
At present, no, we are not providing that one, but what we are planning is, we are taking this, once book is ready, going to, I can say, ACT and CBSE, giving there, and we are telling this methodology can be given to +2 level. Otherwise, we can't go everywhere. And but now, if people are coming to Coimbatore, we are ready to take. It's a 1 week program, 2 week program. Otherwise, we have no other plans. Of course, we are doing now in the January or February. We are going to conduct a workshop. Our theme is this: how to complete entire core engineering. Okay, electrical, electronics, computer science, AI, data science, I can say robotics in 2 years. That is possible now. Okay, then next 2 year work on projects, or AICT is proposing now 2 year course sandwich with the 1 year industry, then come back. That is the AICT is proposing now. But now that is possible if and only if all students learn entire AI and basics of all the subjects in 2 years, and that is possible now. ChatGPT type of all the latest technology allows you to learn extremely fast. Only thing is you should never learn for writing examination. You do for not learn for doing newer and newer projects. Industry wants only that one, not your degree.
Correct, sir. I agree. Thank you. Thank you.
Hello, sir.
Yes.
Hello. Hi, sir.
Sir, can I know more about the 2-week program, sir? Where can we register for this?
We'll, because now we are planning only. I'll inform the madam who is arranging this one, because now our team with the IIT Madras, everybody is facing this problem, because industry needs now full-fledged engineer, not in one area. One area is no meaning now. Okay, so all put together, and everything can be learned. MBBS also same thing. Okay, already now, just to tell you, when you ask this question, because why you are clubbing together. In international, there are already two, I didn't say MBBS course, not MBBS, medical course. 6 years, you get 2 degree, engineering and MBBS. Okay, that is now, that they started 2019. Now, if any government wants to reduce MBBS to 2 years, it is possible. Just like engineering now, 5-6 engineering, you can give in 2 years, all the basics. Okay, only thing is, take away examination. Examination, some no, daily basis, something here and there may be there, but now most of things now, final exam, we are replacing with the projects. Through projects now, you start applying and show your creativity. For that only, we want to give marks, not for your, I can say, by hearting. There is no need of anybody to by heart anything now. Okay, so we'll within 1 month now we'll inform you. Okay, we are planning that syllabus now, because that is some groundwork is required, because we are putting all engineering in one. Okay, tell me.
Sir, very good evening, sir. This session was truly insightful for me. Sir, actually, I come across in LinkedIn our Amrita University pages regarding artificial intelligence, which like many articles will be posted there, like IEEE Computer Society regarding student branch chapter. So it truly inspires me, since I am studying this BCA online. I cannot able to contribute anything. Honestly, I have this 4 years of gap to my studies from plus two to this BCA session. And if I want to contribute or wants to participate in a hackathon, I am truly like, I don't know anything. I don't know what is the path also to participate. And I don't think for online students have many opportunities. So if you guide on this, it will be very helpful to it.
Okay, this anyhow, I want to tell one thing. Our success, because success is we got because of our evaluation process, project based only. Last year, international hackathon conducted by Harvard, our students, second year student, got now first prize. Okay, it is because, not because they are too bright or anything. It is because every semester they have 6 subjects to pass. They have to, I can say, do a project. Okay, that helped now even average students to, I can say, go for that one. And this year, many are publishing now. Second years are publishing standard journal papers. Okay, because that is possible now, provided some hard work is good and this now fundamental maths. So your question is, we already have now 500 students per batch. First year, 8 batch. 8 batch means now around 500 students. That is there. This is how you are training now, at least. I don't know whether you answered. You want the guidance for hackathon.
Yes, sir. Sir, actually, my stream was in +2. It was by PC, and some unexpected things happened to me, and now I wanted to pursue this computer science, so I took BCA. And it's probably 8 years, I guess, since I'm familiar with the math concepts and formulas. So I was trying to go through +1, +2 math subjects as Naina Madhu ma'am told me to look after that. But honestly, I am blocked for a while. I couldn't able to understand properly. I felt like uh, it is very far from me. But as you said, projects are very important. I truly agree. I started to work on some projects, but lack of guidance in a proper way. So that is what I felt that would be very helpful if someone could guide regarding things, projects, and hackathons.
Okay, you can contact our faculty. Anyway, a lot of students are now all the I don't say bright students are into hackathon, and we are giving some training. So if you are you can contact some of our faculty. Those who are we have 2-3 faculty basically meant for training training hackathon and say this competitions. Okay.
I
So
once
Thank you, sir.
wrote an email to CS officer, but I did not get response properly.
You will be getting a response very soon, and we'll be taking care of that as well. Thank you, sir. Thank you for
okay.
everything. Yeah. Right now, we are going to wrap this session. Thank you.
Okay,
Thank you
okay,
for
fine.
delivering such a masterful session on the pseudo inverse of a matrix and its wide range application in machine learning and generative AI. Your ability to distill complex mathematical concepts into accessible insights while connecting them to cutting edge practices was truly remarkable, sir. You have addressed all the questions from our enthusiastic students with utmost care and patience, and we are truly grateful for the clarity and generosity you brought to the session. It was a privilege to learn from someone with such depth of expertise and clarity of thought. The session not only enriched our understanding but also sparked meaningful curiosity among participants. We hope to get more sessions with you, sir. We are deeply grateful for your time, generosity, and intellectual rigor you brought to this discussion. Looking forward to more opportunities to learn from you in the future, sir. Thank you. Thank you so much for all the participants and you as well, sir.
Okay, fine. So all the best.